Our next speaker is Annalisa Jones. She's from Dr. Martini's lab, good friend of mine at Utah State University. Annalisa is a first-year master's student at Utah State. She completed her bachelor's degree in food science at Brigham Young University in 2020. She joined the Utah State team, and she's been involved in the club presidency, product development, College Bowl, and research in Martini's lab, Dr. Martini's lab. And her research is focused on understanding and improving butter functionality in laminated doughs. So the title of her talk is Relationship Between Butter Physical Properties and Water Loss in Laminated Pastry Model Systems. So welcome, Annalisa, and thank you for presenting with us today.
Thank you, Doug. Okay, picture this. A thunderstorm hits and rain comes pouring down. As soon as you hear the rain on the roof, you've been trained on what to do. It's time to collect buckets, cups, bowls, pots and pans, whatever you can find to catch the water leaking through the roof. You have to save the sofa, the dresser, the carpet, or the hardwood floor from the constant drip. If you have lived in an old house or even seen a movie of someone who's lived in an old house, you know the scene I'm describing. Although the leak may be ever so small, you still make the effort to protect your home from the rain outside. Eventually, this tactic of catching rain will get old and it's time to fix the roof. In my research, I'm not fixing leaky roofs, but I am working towards reducing a different kind of leak. My name is Annalisa Jones, and I'm studying the relationship between the physical properties of butter and water loss in a laminated pastry system. Now, laminated dough is made up of two major components, the dough and the butter or the fat layer. The pastry is prepared by folding and rolling these layers over and over again to prepare one giant piece of many layers. The pastry is folded and rolled and folded and rolled over and over again, and that creates the layers that help with rise. Both the butter and the dough layer are important in the proper rise of the pastry and the texture. The butter acts as a barrier between each layer, helping the layers cook separately, but also acts as a barrier from any water in the system. When the pastry is cooked, the water in the dough evaporates and turns to water vapor. This water vapor is trapped underneath that fat layer, and it's what causes the rise, creating air pockets in the dough. This allows for the flakiness and rise of croissants or puff pastries that you enjoy. However, the pressure of the rolling process takes a toll on the butter. And just like your leaky roof, the water and oil emulsion of the butter breaks and water can leak out of the system. This is one of the major struggles that we've seen and that we want to combat. In order to combat this leak, we can't simply catch drops of water like we would with pots and pans. The butter needs to be strengthened. I've studied the properties of commercial butter in order to identify what characteristics are correlated to water loss. We initially identified the amount of water loss in each of the commercial butter samples. This was done by following a procedure similar to the one I just described, folding and rolling, but in this system, we simply used filter paper instead of dough. We rolled out the butter samples in between the filter paper, took samples of that butter after rolling, and measured the water content. We then compared it to a butter that had not been rolled out, just the simple control. And these are shown in this chart. The control in the blue bars and the rolled samples, or like the after rolling samples, in the tan bars. Using a two-way ANOVA, we identified which of those had a significant difference in between the samples. It was identified that 5 of the 10 samples had a significant amount of loss, and these samples are all commercial butter samples. After identifying the amount of loss of the rolled and the control butters, we tested the physical properties on all 10 samples, including melting profiles, solid fat content, water droplet size, rheological properties, and hardness. We then performed a correlation analysis to pinpoint trends related to water loss. All characteristics were tested for correlation, but I will only cover the significant results. In the end, we identified a negative correlation between the solid fat content at 30 and 35 degrees Celsius, as you can see here. This indicates that a lower amount of solid fat content in the samples at temperatures above room temperature followed a trend of higher water loss. Melting profile, including medium melting fraction, enthalpy, and onset and peak temperatures of the high melting fraction were also negatively correlated with water loss. Hardness was similarly determined to have a negative correlation. We're in the process of analyzing further testing to understand all the correlations. Understanding this correlation allows for the identification of the most important characteristics in pastry butter. We can incorporate those characteristics into butter production to strengthen the emulsion of the butter products. If we can fix the butter, we no longer have to worry about the leak. Thank you.
All right, thanks, Annalisa. That was a great presentation. I really liked your comparison. So we're going to open up your paper to the judges, and I'll let them decide who wants to go first.
I can go first.
Good, thank you.
First, Philippe.
Okay, Annalisa, thank you for the nice story. Nice presentation, a good pace, very clearly told and also illustrated. It's a very interesting topic because this is really something which is happening in industry, and all the industries using butter in laminated dough have this problem. So it's really something also seen in Europe. I was very interested by your folding method that is also on your poster. You didn't show it in your pitch, but am I correct that this is like a pasta sheeter that you used to compress the butter? And did you then do that continuously sometimes, or it's only one compression?
Yeah, so our full process, we would take the filter paper, put the butter on it, and then put another piece on top and roll it through the pasta maker in order to make sure it's consistent with all of our samples. And so we started at like the largest gap that we could do, and then went down to the 6th setting. And we did that because we tested where we're seeing the greatest amount of water loss and where we can see that emulsion breaking, and we noticed that was right at that setting. So we went through every setting, starting at 0, going down to 6, kind of to mimic that same procedure as in laminating when you are layering it slowly one
nice approach. Yeah, indeed. In your poster, you mentioned also water droplet size distribution was determined with NMR, but I don't see results.
Yes. So
on the poster. So I'm just curious, is there a lot of influence or relation with the water loss and the water droplet size?
We didn't see a strong correlation, and that was actually really surprising to us. We thought that was going to be a bigger factor. That is something we want to look further into.
And what was around the mean value of droplet size in your butters?
It was right around, let me pull up the stats. Water droplet was right around like between 5 and 7, which from my research of other papers, that's pretty typical for commercial butter.
Okay, final question from my side. How does a producer of butter can influence the water loss? What do they need to do to prevent water loss?
Yeah, if we're looking at those correlation factors, we are wanting like a harder butter, and then we're also going to want something with a higher melting fraction, because if we have a higher loss, a lower solid fat content at like 30 or 35 degrees, then that's pretty highly correlated to water loss. But if we have
do you think a producer can influence that?
I think that you could, one of the things we want to actually study in the future is fractioning the butter fat. So being able to fraction out those portions, and then you could influence the amount of.
Yeah, and then you can do reconstitution to the desired amounts. Okay, thank you. Exactly. Nice.
Yeah, if I go. Yeah, go ahead, Amanda. Okay,
yeah,
go ahead.
No. I mean, Annalisa and Philippe covered most of the topics I was planning to ask, but
sorry, Amanda.
Now, Christophe. No, that's great. Annalise, really great job. I was really surprised to hear that you're just in your first year of an MSc. Congratulations on so much progress to this point. And we'll look forward to seeing you at AOCS in the future, I'm sure. So congratulations, and you told a really nice story with the leaky roof. Thank you. I was curious. You talked about formulating butters with a higher solid fat content at 30 degrees or 35. And I was thinking, how specifically would you recommend to somebody to do this right now? Is there a strategy you see that's viable?
Yeah, kind of what I was saying before. I think really that fractioning out of the butter, in our future studies, we're planning on taking anhydrous milk fat and fractioning that and then adding it back to our cream to be able to see if that's going to change the effect. And so that's something we're planning on studying in the future. But I think that fractionation of the butter fats is something that could help in that.
Did you do any fatty acid determination of the different butters?
We didn't in this study.
Do you have a sense of whether they would vary significantly?
Honestly, in this one, I can't say that I do. We got all of the, just from the different manufacturers, it would be really hard to tell based on where they're getting their milk from or things like that.
It would be really interesting to see that. In Canada right now, we're facing something called Buttergate, because anecdotally, people were reporting during COVID-19 that butter seems to be a lot harder. And this has led some people to postulate that it's related to increased feeding of palm stearin and palm fat in the animal feed. And so it's blown up into the news media a lot significantly. So I'd just be interesting to also keep in mind this possible relationship between slight differences in fatty acid composition and the hardness and other factors. So really nice job. Thank you.
That would be very interesting. Thank you.
Yeah, Amanda touched a very good point. The change in composition, winter versus summer, or the feed, I think that can have an impact. I think you started very well with that, the raindrops or the drops coming in. And I originally am from India, so I know that if it is rains, if you're even within trees, the leakage and all that. So that was a good start. And so we had a French baker in our application lab. He would always say that, oh, don't bring margarine to my croissant. Let me work with butter. That's probably what people like. So I think it immediately reminded me that, yeah, butter is definitely the preferred fat phase in, croissants and other pastries. But it's quite expensive, right? So in many countries, people do a recombined butter, what Philip was touching base on. They would take 60% or 70% AMF and put water inside, and with emulsifiers and high shear, they would still get a beautiful droplet size distribution, 3 to 4 microns on a 50% distribution, which is quite good. I think much smaller than standard ones. But I think if you can look into, I don't think I have any specific question, but I think your final conclusion, the looking into different fractions of butter, the high melting. And I tend to believe that if you remove the mid melting fraction, the high melting with some liquid oil, a little bit of that, health issues or whatever, that could be interesting. But one thing, what was the ambient temperature of your room when you handled these butters? What temperature was it? In your lab, what was the room temperatures approximately? I need to convert to centigrade. So you probably will tell me in Fahrenheit.
I do not actually know the specific temperature of our room when we were
because that could, I think that would play an important part, whether it is 18, 19 degrees or in the 23s or something, that would affect, right?
I think that's very true.
And also that for every time you take out a sample, is it tempered to the right temperature? If you have a series of samples, are they all lying in the room, or you're taking out from a particular temperature cabinet and then trying to laminate? And another point was that I've seen, what was the shape of your butter blocks? Were they like big cubes, blocks like brick, or plates, more like plates?
It was bricks, but not big bricks. It's like a pound of butter, but split into 4 bricks, basically.
Because, many times, I'm just showing at coffee. Sometimes if it is like this block and you have to squeeze it down to a thin layer, then you put much more pressure on it, right? Breaking the structure. But many a times in the industry, they will sell it as plates, pack it as 2 kilo plates. So they don't need too much of compressive force. So maybe next time, if you can, talking to any company that, if you slice it and see the effect from starting from a chunk of butter to a slice of butter, a thin sheet. So that could be interesting to see that effect.
Yeah. Sorry, I misunderstood your question. When we rolled it out, we did slice it. So it wasn't.
Okay. Okay. Sorry, I wasn't too clear. I think maybe it's
Oh,
10 o'clock.
that's okay.
But I think it's very interesting. So yeah, thank you.
Thank
Good
you
job.
so much.
Thank you. And one comment question from the audience. Dear Annalisa, maybe you lose oil too, but not water, question mark. So I think they're wondering if you're losing some
So
of the oil as well.
that's a good point. I think that would be represented in the water content as well. We tried the same process with margarine, and we actually saw that we did see oil loss with that one more than we did with butter, but that would be really interesting to study.
Thank you so much. Wonderful topic. Great paper.
Thank you.